Herkese merhabalar. Bugün dönemin son Nano Open'da karşınızdayız. Çok kıymetli bir konuğumuz var. Profesör Doktor Bedir Tekinerdoğan. Bedir Hocam hoş geldiniz.
Hoş bulduk. Merhabalar.
Mikrofonu kendisine devretmeden önce hakkında kısa bilgi aktarmak istiyorum. Ee, Bedir Hoca bugün bize dijital ikizler ve yapay zeka hakkında bilgiler verecek. Profesör Doktor Bedir Tekinerdoğan yazılım, sistem mühendisliği ve bilgi teknolojisi alanında 25 yılı aşkın deneyime sahip bir bilgisayar bilimcisidir. Hollanda'daki Twente Üniversitesi'nden 1994 yılında bilgisayar bilimleri alanında yüksek lisans, 2000 yılında doktora derecesini almıştır. Profesör Tekinerdoğan 2003-2008 yılları arasında Twente Üniversitesi'nde çalışmıştır. 2015 yılına kadar görev yaptığı Bilkent Üniversitesi'nde yazılım mühendisliği araştırma ve eğitimini teşvik etmek amacıyla Bilkent Yazılım Mühendisliği grubunu kurup yönetmiştir. Şu anda Hollanda'daki Wageningen Üniversitesi'nde profesördür ve Bilgi Teknolojileri grubunun başkanıdır. Stanford Üniversitesi'nin yaptığı sıralamada dünyanın en iyi %2 bilim insanı arasında yer almıştır. 400'den fazla bilimsel makale ve 10 editörlü kitap yazmıştır. Çeşitli büyük yazılım firmalarıyla onlarca ulusal ve uluslararası araştırma ve danışmanlık projelerinde baş araştırmacı ve lider yazılım sistem mimarı olarak yer almıştır. Tüketici elektroniği, kurumsal sistemler, otomotiv sistemler, kritik altyapılar, siber fiziksel sistemler, uydu sistemleri, savunma sistemleri, üretim hattı sistemleri, komuta ve kontrol sistemleri, fiziksel koruma sistemleri, radar sistemleri, akıllı sistemler, ölçüm sistemleri, enerji sistemleri ve hassas tarım gibi alanlarda deneyim sahibidir. Hocam tekrar hoş geldiniz.
Hoş bulduk.
Etkileyici bir özgeçmişiniz var. Benim atladığım noktalar varsa siz de aktarırsanız memnun olurum.
Çok teşekkürler Nokta Hanım. Çok teşekkürler. 50 yıldır Hollanda'da yaşıyorum. İşçi ailesi çocuğuyum diyelim. İlk Türk işçi ailesinde ilk Türk profesör sayılırım Hollanda'da. O da ilginç. Yani bir milestone. O açıdan söylüyorum.
Harika.
Toplum olarak önemli olduğu için. Birçok böyle başarılı Türk insanlarımız burada devam etmektedir farklı alanda. O da sevindirici bir olay tabii. Sunumu İngilizce'de yapacağım. Daha önce konuştuğumuz gibi.
Tamam.
Eee, Yani bir şeyi açayım, paylaşayım
Evet, ben
isterseniz.
durdurdum hocam. Buyursunlar.
Tamam. Thanks a lot again for having me, for inviting me for this interesting discussion series. It's a webinar. So my talk today will be about digital twins, and on the other hand, AI, and then we'll check the what's the connection. I will start slowly and then discuss the evolution of digital twins. What is it? Where are we now, and where are we heading towards? What is AI, and how do we use AI in digital twins? I am at the Wageningen University. Wageningen is a small city in the Netherlands, so it's like 40,000 population. And there's, of course, it's important for is university, Wageningen University and Research. It's a life sciences university. That means like it's especially focused on life sciences, including what is life. So we are human beings, plants, animals, environments. And food systems, etc. So the university is structured like that. My chair group is in the information technology group, is in the social sciences. And we are one of the 21 chair groups. And then besides of that, so that's an interesting structure. There's also research institutes, which are also there for the Wageningen University and research. Their goal is actually to do a project-based research and collaborate with us with the intention to create value, right? So that's the value for the Netherlands, for the world. That's how we actually collaborate, how we do research. This is our group, about 40, 50 persons. When I started, this is my 10th year. When I started, we had like 8 or 9 staff members. We have just 2 PhD students, but now we have about 25 PhD students. The dramatic increase of research papers and projects, etc. Plus, what's also interesting, there are people, staff members, I should say, also including postdocs and PhDs from about around 20 different nationalities all over the world. And so we have created a nice, safe research environment where we actually all grow together. So that's quite a nice environment. So we teach a bit shortly about our group. We teach information technology group, but it's a kind of computer science group. So we teach courses on Python. We, for example, 600-700 students per year, and we take our course or software engineering course where we teach Java. We teach R, we teach, and then about 80-90% of our course are data science, AI related. We were the pioneers in big data, and then the new course, linked data, data science concepts, AI. So we started 3-4 years ago. That's what we do. We also have the data science minor. My own background, you can find on LinkedIn. I will be happy to connect. Just connect. So you can see the whole story. As you can see, so my story in the Netherlands started in 74. I was not born in the Netherlands, but I was born in Turkey. But I didn't go to school in Turkey. So it's all my started primary school in a small village in the Netherlands, and then the gymnasium, ateneum, what they call the high school, university, and then we just followed our path, and so and we continue. So success is not a destination; it's a process. The outline of my talk. So as I said, I will give the outline of what digital twins are, and then show what's the relation to AI. So I will do it slowly. So we will discuss the notion of document-oriented development, model-based development, model-driven development, and these are the stages in the evolution of modeling. And then we will see how digital twin is the next evolution. So it's not just a temporary hype. That will be my statement. And then we will see that AI is closely related to that. That is like if you want to have a successful digital twin, it is required that we need or that we apply AI, and that's actually the message today. This is a Hollywood movies, Surrogates. Don't know whether you have watched this, but this is about. So shortly, I will not try to give spoilers, but about human beings who are just safe at home. And on behalf of them, there are robots live actually. So they go to work and to the city, but all the human beings just stay at home. This is typically the analogy also with digital twin. So on behalf of the physical entity, there's some digital entity, in this case, a robotic entity. And what we also see is like the physical entity is directly connected to digital twin entity. And so there's a close connection, and that is important. And that it also defines the digital twin approach. And so I will come to this conclusion. But if we go far back in history, so we didn't have modeling at all, right? So we start with physical objects, but then after some time, so when you develop small systems, for example, pottery, you don't typically you don't need the drawings. But if it gets complex, you have to need to draw it, and then there started the idea of models. What we also say like the design blueprint. And that is the design. The model is as a kind of blueprint for the physical object. But the connection here is there's no connection, a real connection. We just based on the blueprint, we develop the physical object. And modeling, as you know, can be used in two directions, right? So here, from based on physical object to blueprint, that's possible. So I can look at, for example, the traffic, the roadway, and then develop a kind of model with the goal to analyze, to understand, and maybe to redesign, do some adjustments. And also the other way around is of course possible. You can have a model which prescribes how to develop your physical systems. Anyway, right? So, but we have a design blueprint and a physical object, and actually the connection is loose. That is like there's no formal connection. Well, that is the other notion that is also important in this context is also the document-based systems engineering. We can do modeling, right? But it can be also informal. We can just put it in our Word documents, PowerPoint, Excel, whatever, but it's not formal. And that is used also, still used sometimes in some companies. But you miss lots of opportunities if you do it like this, right? So the box and line drawings approach, because it is difficult to understand these models, to use these models to guide the development of your system, to analyze, etc. It is used for ID creation, concept creation, but not very useful for example, guiding the process. So instead of that, so we have moved to model-based approach. That is like, let's model in a proper way. And so there are also standards like Unified Modeling Language, SysML, System Modeling Language, which actually provide de facto standard notations to model our systems. And the models, they have their one interpretation. It's just not subjective. So if you see a UML model, it has one meaning, and that helps to actually to analyze, to understand, to guide the system. See, that's also we have seen this shift from document-based to model-based. Plenty of advantages here, right? So if I put them here in the table, document-based versus model-based for change management, visualization, collaboration, traceability, complexity management. Model-based all performs better, right? So we don't model for fun, but we model for a purpose, right? So that's model-based. But then there was in this, we also saw another development, model-driven development, where we say like we have in the normal case, even if it's model-based, we have these requirements models, analysis models, design models, coding, implement, etc., etc., and we develop these models. Whatever life cycle it is, it can be agile, iterative, whatever, but we have these models. But the link between these models, the connection, and there's no connection. It's informal. And what is done in model-driven development, what is said like, let's make it formal, and let's make the link between these different models, and let's generate the next level models, not by human beings, but by our programs which generate the next level. For example, I provide the requirements, and I have a generator which creates the code, right, etc. And that's called model-driven development. Model-driven development. And you see, it gets more automation. So if we wrap this part up, so if we summarize this part, we can see like we can talk about maturity of models. Right? So on the one hand, we can have sketch, which is typically the case in document-based development. And then we have like model-based, where we use blueprints. It's more detailed models, which are quite precise. But the point here is like the interconnection between these models is still informal, and so we need some human beings who should do the development, etc. And then the third part is the model-driven development. It's more executable models, or models are so very precise that we can hand it over to for example, code generators who can automatically create the code, or for example, in systems engineering for 3D printing, that's typically at this level. That's what we have seen. See, so document-based, model-based, model-driven. That was very nice. It is quite nice. And then, what if we take a critical look at this? We can say like, yeah, that's nice. Okay, you have requirements, design, realization, and we can deliver this. This could be model-driven, but still, once you deliver it, there's no connection anymore with the model and the product. See, so we still have the maybe automatically generated models, but the connection with the product, with the system, it's gone. Right. So, and if you want to redesign or redevelop, we have to regenerate. And there's what we have the notion of digital twins. Right? So I've described this whole story in this article last year. You can read it there, but this is where we you see the next step of digital twins. Digital twins says like, yes, okay, we have this model and the product, but let's not lose the connection, and let's keep the connection, and that's very important. And there's a direct connection with the digital twin. That's the model, executable model, and the physical model. So as such, and a digital twin is also a digital replica, we say. That's what we say, like it should include a rich representation of the physical object. It's a connection and rich representation. And if you have this structure, you could say like, well, we can do the analysis here, the simulations here, the what-if analysis, the prediction, we can the monitoring, the control, etc., etc. Right? So sometimes we cannot directly use or impact or work on the physical object. We can then instead we can look at the digital twin entity. That's the story. Yeah. So that's, and the digital twin can start early in the life cycle. So this is shown here. Already here in the digital twin, we can start directly with the requirements, design, until the implementation. But even after the retirement, or when the system dies, right? So we could still have a living digital twin, right? So we could say like, if you would have a digital twin for human beings, it could still even live forever, right? So even if we die, right? So, or for any product, then that is quite interesting. So there's a continued connection with the physical object. This was not the case before in history. We had these formal links with automated generation, etc., but not the direct connection. And digital twins can be at different levels. That's so at the component level, at the system level, at the process level, whatever level you decide, and then you could have like digital twin to physical twin or physical object. That could be one-to-one relation, or one-to-many relation, or many-to-one relation. See, that's all possible. Excuse me. This is the history. Excuse me. So look at the history. This is like 10,000 years of history, you could say, like, because if you look at the known models, that was the large part of our history, just farmers and hunters, etc. But and later on in the history, we said like we need sketches, and based on that, physical objects were drawn. And then later on, again, said like these models should be more precise, blueprint, and especially in engineering. UML system, all this and that, but here there's like the informal connection, and said like, let's have these models, but let's generate the models here. And the code generates 3D printing, and now with digital twins, we still have a model. Right? You see, executable model, but they say like, let's not lose the connection. That's the history. Right? So again, I've put it here in this article. So from this perspective, we say like, wow, that's interesting. And this is not just a hype. It's not just temporary. No, it's just the next step in the evolution of modeling. And that's, we could say, yeah, why now? Right? If I go back, this idea of keeping the connection with the models, well, it's not that difficult if I think about this, but 20 years ago, this was not possible. Let's keep the connection with the physical object. And the reason was because we didn't have the computation power, and we didn't have the storage, data storage. We didn't have the sensors. We didn't have the actuators. We didn't have the bandwidth. Everything was slow. You see, but that has also changed. And so we see also the evolution of digital, from digitization to digitalization to digital transformation. This is a LinkedIn article where I try to summarize this. So that has led to a disruptive change, and that has this digital transformation has also enabled for example, the notion of digital twins. And that's the reason. And so we have written several articles. So I will just and this article is from several years ago, 21. Here we have defined the ontology of what digital twin is, and typically what we make the same with, like, it is a control-based system. I will show in next slide. And this one is more about when you develop system, what are the design patterns? And we have identified 9 design patterns for designing digital twin-based systems. Let's look at the underlying idea of digital twins, what we have proposed. Said like it's a kind of the main decomposition that is required is control system. Control system is like, indeed, we have physical object. It's a very at the high abstraction level, I should say. But what we do is like we have to observe the state of the physical object, right? And we can do that through sensors. We get the state that is provided to the comparator. Which is that's a kind of element which checks the goal of the system, and then it checks for example, the temperature control system. It says like I want to have like at 20 degrees, and it says sensor is 15 degrees, and then it can provide there's a delta. So then based on that, you can say like you make a decision, you heat up or cool down, and you could have sent a command to actuator or effector to update the state of the physical object. Control system, right? There are control systems are everywhere in our lives, right? So at home, in the cars, in the office, everywhere. So and then we have like this how does it fit to the idea of digital twins? Well, on the one hand, we have the physical object space, right? So we have physical object. We have the sensors and actuators that are at that level. And on the other hand, we have the digital object space. And there's the digital twin. Here's the physical twin. Here's the digital twin. I call this digital object space because we could have like multiple digital twins here, and the same here for physical twin. And then here's like where's the control? Well, we get the state here from the sensors. Then here's the rich representation of the digital twin. And we check the state of the digital twin which represents the physical twin. Based on that, the deltas are defined and the commands are selected, which on their turn actually act and change the state of the physical object. Okay, then that's the story. And so control system, and then we put in the digital twin. Several terms that needs to be known here. I already said like the notion of physical object and virtual object, or the physical twin and digital twin. Then we have the idea of a physical environment and virtual environment. That includes the physical objects and digital twins here. The state realization, act of changing the state, metrology, the measuring, the twinning. And the twinning, we said like there should be a connection between the physical object and digital twin object. And so we need to, at sometimes real time or near real time, we need to observe the state. And there's the twinning rate, and then we could have like update the connection of physical to virtual and vice versa. Well, that's the basic ontology, and then we said like as I said, I will not elaborate on this too much. We can also we have for different contexts we need different kind of digital twins. I'm dit çalışıyorum, so I'm working at home. All right, sorry. So there are like 9 patterns, right? So like what we have identified: digital model pattern, generator pattern, shadow pattern, matching pattern, etc., etc. And this is open-ended. So this is the idea of which you can read here in this paper. I will not elaborate on this because here I will focus on what's the relation with AI. But the idea is like digital. There are different solutions because different problems, different solution structures. And so, okay, if we look at AI, and that's like what is AI, right? So artificial intelligence, of course, it started soon after the invention of the computer, as you know, and then with Alan Turing, etc. And then soon, right? So but there are different definitions. We could say like it's about acting smart, thinking smart, right? So, and that can be based on the human beings or based beyond human beings. Right, so we could have like this structure, which is nicely explained in this book: thinking like a human, acting like human, or thinking rationally beyond human. Right, so we want to have the rational reasoning, so or acting rationally. Right? So that's a kind. Right? So that's the way how we see it. But we also see like the based on the capability, we can identify different categories of AI, which is important. Yeah, which is important. We can say like, well, we have narrow AI or weak AI, also called, right? So here we use AI for a particular domain, right? Such as chess, right? So or some games or whatever, some well-defined domain. That is artificial narrow intelligence or weak AI. Artificial general intelligence, AGI, also known as strong AI. Here it's like the machine just mimics or resembles the human being, right? So it can just think and act like a human being. The next level is even further than that. It says like artificial superintelligence. And here we have the notion of so-called singularity point, which means like there will at some point it will reach artificial general intelligence, and after that it can recursively improve itself, and that can go very fast. And after it will be transhuman, and it will have intelligence not beyond a single human, but also of the whole planet. And that's the idea. Artificial superintelligence. And for this artificial superintelligence, right, it's all human beings are just like idiots, right? So that like because it's very, very, very, very, very intelligent. Well, the point here is like at what level are we? Yeah, of course, many domains are just like weak AI, a narrow AI. We have not reached yet the notion of artificial general intelligence. But the idea is some say like we will soon reach that, right? So, and there are of course discussions about the risk and the threats, etc. So, do we want that, and we should be careful, etc. These are all ongoing discussions. If we ask, will we have an AI winter? What's that AI winter? AI winter, we have seen that in the history. It started early on, like already in 1960s. Like they said, like, oh, we have a computer, so it thinks, it's a thinking thing. It will soon replace us. So that was like a huge confidence in AI. But after a while, they said like, they saw the limitation. They said like, wow, no, this is just science fiction, will not work. So the funding and the research in AI stopped or delayed, and that is called AI winter. And we had several AI winters in history. The case is like that's my opinion. I think of many people. We will not have an AI winter again. That is like because why did we have AI winters before? Again, the idea of like low computation, storage, expensive, but also the idea about what is intelligent. The cognitive models were also not that well defined, but now it's in the history we are further, right? So we are quite far, and if we take a specific domain, we can apply narrow AI. And so we don't have a AI winter for the narrow domains or specific domains. But the idea on artificial general intelligence, that's still an ongoing discussion. Will we have that? Yes or no? Will we have an artificial general intelligence winter? Yes or no? Yeah, we will see. Right? But developments are go very fast. Right? So we now have, for example, ChatGPT 4.0. Quite impressive, and all the others, right? We don't know, well, we know that the higher level versions will definitely do more, and that will resemble, of course, the AGI, or will be quite close. Well, if you look at the AI approaches, so AI by itself is quite broad. A bit more about that. Of course, like AI, we could say it's part of it, computer science, but also it's a multidisciplinary, we could also say. But an AI itself, and within AI, we have machine learning, and deep learning is a subset of that. We have data science, right? So it can be done using machine learning, and we have big data subset. This is pretty the relations. And if you look at the machine learning, what does it do based on developing machine learning models based on data, and data is just observations, right? Develop a kind of model and use that model to do the predictions. Just actually like what we do in theory building. We look at, we make some observation, we create some theory, and we use that theory to predict something. It works pretty the same, right? So, and there are different approaches in machine learning, right? So as you might know, you could have labeled data, unlabeled data. You could have reinforcement learning. And there are some variations, as supervised, unsupervised, semi-supervised, etc. And of course, like if you look at deep learning, neural networks, it's a part of it. There are different algorithms, different structures. It's increasing. And so besides of that, right? So NLP, right? So computer vision, robotics, expert systems. Right? So some of these are more generic, others are more a bit more towards application, but these are important AI techniques. I've put them in this such a kind of, we call this a feature diagram. It's not complete, but if I don't know whether you can see it, AI, it can be AI capacity, functionality, and then the machine learning, deep learning, NLP, and then there are different kinds of techniques. Here you see the commonality variability. This I will present in 2 weeks in it, the System of Systems conference, in this paper, where I actually consider it more from a strategic perspective, right? So for integrating AI, not in digital twins, but system of systems, right? That's like we have systems, and these systems are connected, and then we talk about system of systems, and that's there we can also use AI, but there's also a whole strategy how to start, and that's the story in that conference paper. Okay, if we look at AI, so that's like we have there's a whole all these approaches, but the role is also interesting, important to know. We also look at which extent do we want to have AI. And there are notion of human in the loop, on the loop, and out of the loop. In the loop is like, of course, right? Also traditionally we have a AI system, but human is still in reasoning it. On the loop is like the AI system does everything, but the human controls whether everything is safe, it's secure, whatever. Human out of the loop, the thing itself gets quite independent, right? So typically AGI is like that, right? So and in a similar sense, we could say, yeah, but we have also like we can also take like a look at consider from the machine perspective. Is it out of the loop, in the loop, or on the loop? But these are issues that we also think about also when we develop digital twins. There are criteria for adopting AI. We check like can we use, and that's also in the paper that I had like for system of systems. Here are 5 criteria that we typically use. AI is very often very data intensive, so we need like data. Is data available? If it's available, can I access it? Like is it? And then we have these, for example, FAIR principles. Is it findable, accessible, interpretable, reusable? Has it the right quality? Is the complexity of the concern, is that at fault? If it's simple, why can't do it? Why AI? Repetitiveness, potential for enhanced decision making. If we can say like, no, the AI can make better decisions, more precise, which happens in many domains now. And then we have the discussion about, oh, it will replace the human beings. Yeah, but it is better, right? So you cannot stop it then anymore. And of course, cost benefit analysis. It's not always easy. So you have to do some investments. Of course, like, is there the knowledge? So you can say, like, you have to know all these things. These are criteria, but and if you look at the data parts, of course, you can do like different analytics. You could say like, I want to describe what has happened, and descriptive analytics. And this can be done using machine learning, of course. Like, why has it happened? Diagnostic analytics. What will happen? Predictive analytics. And the most advanced, and maybe like which provides us the highest value. What should we do? Prescriptive analytics. And this is the whole machine learning lifecycle. You can find it on the web. There's like you train a model based on data sets, a feature engine, if you have traditional, but with deep learning not necessary, etc. And you have the model. Once you have that, you can do the prediction for new data. And with this, we can do descriptive, diagnostic, predictive, prescriptive analytics. Okay, let's look now at digital twins, a few more slides, and then we are done. So for digital twins, we said like this is the control structure, right? So we separate the physical object from the digital object. And then we have like we said like, yeah, what we have to identify the concerns, right? What is happening here, which are listed here, life cycle stage or lifestyle or the concern digital twin. Which means like, well, I need to do data collection through sensing. I need to store, right? So for rich representation of the physical object, I need to process that data. I need to do analytics, maybe descriptive, diagnostic, prescriptive of the physical object. I might need to simulate this. I might need to visualize, then decision making, and I might need to give feedback and control. And here are all different functions, right, that we will need to implement such a digital twin-based system. Well, where is this AI? Yeah, if you look at this, and we can all think about how can we make these steps smart using AI. That's the question. And here's the table that I've put. Data collection. There are some concerns or functions I can use for different. These are just examples, I should say, yeah, or generic examples. We can invent others. We can do anomaly detection, data cleaning using AI, organization, data processing, and all these things. And so here I've put also the techniques where we can all put apply AI. So what we realize here is that, and if we go further, modeling, simulation, and the other domains, the idea is like, and the conclusion here is like, well, okay, I can have like a digital twin, but that really is a kind of provides a close connection with the physical twin, and it should do something, right? It should analyze, do analytics, whatever, simulate. It should collect the data, and for all these steps, we can use all these AI approaches. Right? So that's the way of thinking here. Here's just a kind of summarizing point about the with AR or without AR, with digital twin or without digital twin. Here is like you could have like traditionally non-AI, non-digital twin, or for example traditional banking software system, whatever. Maybe it's not smart or whatever, and there's no digital twin. Or you could have AI-based system, but no digital twin. It's possible, right? So traditional or machine learning is not digital twin. Or digital twin, you could have digital twin, but non-AI. That is possible, but then, yeah, but it's quite, it is questionable, I say, because I still need to do the sensing and activating. I need machine vision. I need to do analytics. So the point here is like actually this, if you are talking about digital twins, typically is very, very highly correlated also with AI. That is like a digital twin becomes effective when we use AI approaches. Within our group, we are actively working on digital twins and also, of course, relate to AI because we want to make it smarter. We have a creative technology lab where we do also virtual reality. So typically these digital twins are represented also in the virtual reality or without also possible like in smart farming, etc. So so also the application domains that on the one hand some of the foundational aspects we work on that. On the other hand, more applied innovative research in the life science domain of Wageningen University. Here are a number of related publications that you can check this up. I'm on ResearchGate. Almost, yeah, the majority of the papers are there, are preprints. You can check. If you cannot access them, I'm all happy to send that to you. So what did we say, discuss today? We said like, I started with document-oriented development. And then we said like in the history, yeah, make it formal. That has led to model-based development. And then model-based, we said like, let's automate model-driven development. And we said then the next idea was I keep it connected. That was possible because of the computation power, increased computation power, and with make it smarter. Right, so digital twins. So with AI, we can make smart digital twins, which is actually the most effective way of developing digital twins. That's my story. Thank you very much.
Thank you hocam.
I can have questions if there are any.
Evet, sorusu olan varsa chatten de yazabilirsiniz. Evet, chatte bir soru var hocam. Siz görebiliyor musunuz? Erkan Bey yöneltmiş.
Bir bakayım. Nerede görünüyor?
Tarım, evet, Digital Twins in Agriculture diye başlıyor.
Türkçe'de şey yapabiliriz. Dilimiz döndüğünce
Evet,
anlatırız.
Türkçe sorularımızı değerli katılımcılar, sorularınızı Türkçe sorabilirsiniz isterseniz. Ben chat'i göremeyen katılımcılar için soruyu okuyayım ben. Where can you put digital twins in agriculture? I mean, is it possible to develop model as much as closest to the nature for making decision? In nature, many dynamic environments are existed, and because of the climate change, there will be unpredicted events. In plant breeding, prediction of best varieties will be decided by AI, which can save energy, time, and cost for plant breeders during selection process. What do you think about?
Yes, güzel bir soru. So burada tabii o akıllı tarımda tabii ki o digitalization kullanılıyor. Akıllı tarım mesela normal traditional tarım var. Akıllı şekil hale getirebiliriz. Without digitalization işte o alanda. Ama akıllı tarım dediğim zaman zaten digital teknolojiyi kullanarak. Digital teknoloji de zaten mesela IoT kullanıyoruz, software kullanıyoruz, data science kullanıyoruz. Buradaki soruda digital twin kullanabiliriz. Evet. Mesela şu an zaten IoT kullanıyor, Internet of Things. Şeyler mesela o tarlalar mesela sensörler ekleniyor. İşte sulama, gübreleme vesaire onlar ölçülebiliyor. O şekilde veyahut işte traktörün digital twin'i yapılabilir. Plant breeding için de tabii bizim birkaç şey vardı. O machine learning çalışmalar, deep learning çalışmalar, mesela plant disease detection. Ama mesela o close connection yapacaksak, mesela o şey var, o greenhouse'lar, seralar, o plant, o digital model yaparsam ki yapılıyor, sensör oluyor. Ya bir şey için, bitki için veya birden fazla için veya bütün sera için. Mesela dediğim gibi farklı seviyelerde digital twin olabilir. O connection oluyor. Mesela 7 gün 24 saat. O digital twin seviyesinde de o analitikler yapılabilir. Siz burada örnek vermişsiniz işte plant breeding için o benim alan değil ama orada tabii o farklı sorulara göre bütün o yaptığımız o decision making, analytics, simulations o seviyede yapılabilir. Which can save energy. Save energy evet olabilir ama şu da var. Digitalization ile beraber tabii enerji de bir şey oluyor, bir sorun olabilir, bir cost oluyor, maliyeti oluyor. Ona da bakmak lazım. Mesela data science yapacaksak, bilgisayar kullanacaksak, high performance computer. Ve diğer tarafta o bir tartışma var. So green computing dediğimiz olay. Tamam bunları yapacağız da fakat işte mesela ChatGPT vesaire veya diğerleri gibi veyahut işte data science center kuracağız. Oldukça fazla enerji tüketiyor. O da ayrı bir tartışma. Bir taraftan optimization oluyor. Bir tane akıllı bir sonuçlara varabiliyoruz. Diğer taraftan tabii o social, ethical, legal, environmental sorular da oluyor. Yani buradaki şeyi aslında bütünsel olarak ele almak lazım. Bu teknolojiyi sorumlu bir şekilde kullanmak lazım. Kullanılabilme digital, evet tabii kullanılır. İşte bu şey yapılıyor. Yani bizim üniversitede, Türkiye'de de şey var, çalışmalar var o konuda.
Hocam çok teşekkürler. Başka sorusu olan varsa alabiliriz. Bir veya iki soru daha. Ne önerirsiniz diye Erkan Bey yazdı tekrar. Kendini geliştirmek istemek üzere.
Aa,
Meraklı ama
ya
kaygılı.
kaygılı evet ya işte ya, her şey bizim elimizde biraz işte her şey insanla başlayan responsibility ama şey var artık bütün bilgiler artık açık her yerde şey var öğrenebiliyorsunuz internette açık kurslar var. Ama işte bu yapay zeka çok geniş işte bu temel introduction seviyede başlamak lazım. Şey de önemli tabii bu sadece yapay zeka ile bitmiyor. Bu olay bir de şey diyoruz. Bu interdisciplinary, disiplinler arası. Mesela işte plant breeding'de örnek vermişsiniz. Yani bu plant breeding'de yapay zeka yapılacaksa önce plant breeding çok iyi bilmek lazım. Oradaki süreçleri, oradaki problemleri. Ondan sonra AI'yi nasıl kullanabileceğiz veya digital twin'i nasıl kullanabileceğiz? İşte bu o seviyede işte birden olmuyor. Tabii başarı dediğim gibi tek tek bir hedef değil, bir süreç oluyor. O şekilde ilerleniyor ama e, bakıyorsunuz işte yaptıkça bakıyorsunuz arkanıza bakın o bayağı ilerlemişiz diyorsunuz. O şekilde vereceğim cevap bu yani.
Çok teşekkürler.
Fakat
Hocam diğer katılımcılar sorularını düşüne dursunlar. Benim de bir sorum olacak.
tabii.
Şimdi farklı AI yaklaşımlarından bahsettiniz. İşte machine learning, natural language processing,
Hı hı.
computer vision, robotic and autonomous system, bir de expert system and knowledge based system diye.
Evet.
Şimdi ben de günlük hayatta tabii ben sosyal bilimciyim ve yaptığım iş iletişim. Günlük hayatta ben de yapay zekanın bazı araçlarından yararlanıyorum. Kişisel gözlemlerim bazı konularda daha kat edilecek çok yol olduğu yönünde. Siz mesela nasıl bakıyorsunuz? Hangilerinde daha iyiyiz? Bunu hem olanak bakımından hem kullanım yetkinliği bakımından hangilerinde daha gidecek çok mesafemiz var? Bir de bu AI Winter'dan bahsettiniz. Hani o hangisini ket vurabilir diye soracağım.
Ya o AI Winter şeyde yok artık bana göre. Bana sorarsanız bu Narrow AI için o yok. Mesela bir
Tamam.
alan belirlerseniz, o alanı da çok iyi modellerseniz şey de var bu arada, international katılımcılar da var. Burada Türkçe konuşuyoruz ama kalın. But,
Tamam, benim sorduğum soru,
hı,
özür diliyorum, bölüyorum, 35. slaytınız.
evet
AI
burada,
approaches.
evet bu şey var tabii, o narrow AI o mümkün. Sonra tabii o şeye bağlı, o machine learning'ler oldukça zaten kendisini göstermiş. Orada tabii o yeterince data varsa, veri varsa o kullanabiliyoruz machine learning modelleri. Tamam. It's not rocket science anymore. Hatta araçlar da artık, eski algoritmalara yazardık. Şimdi araçlar şimdi bir şey diyoruz. Low code platform, no code platform. Kodlama bilgi az, bir kodlama bilgiyle bile bir machine learning model üretebiliyorsunuz ve accuracy, precision bayağı yüksek olabiliyor. Kendi içinde tabii o gelişiyor ve hızlı bir şekilde gelişiyor. Şimdi o tabii o deep learning'e geçiş yapıldı ve tabii o hepsi beraber bir şekilde o e, şey olarak, bu teknoloji olarak onlar devam ediyor, fakat yetenek olarak, capability olarak mesela bu çoğu machine learning, mesela bir eleştiri yaparsak linear.
Hı
Fakat
hı.
gerçek hayat non-linear. Feedback sistemler var. Onu pek iyi modelleyemiyor. Ya bir daha şey oluyor, too restrictive oluyor.
Yani bir
Bundan
kısmını
dolayı
değiştir dediğimizde görsellerde mesela onu değiştirmiyor, yeniden yapıyor. Onu mu kastet?
o da bir başka problem. Mesela dün bir toplantıdaydık. Tabii şey var, bir e, veri topluyor, machine learning yapıyor. Mesela bu ama machine learning model, ortam çok hızlı değişiyorsa, mesela machine learning retraining yapman gerekiyor. O retraining de her zaman hızlı şekilde olamıyor. Mesela real time, mesela digital twin'de real time topluyoruz data'yı. Tabii rich representation oluyor. Orada analitik yapıyoruz. İyi de analitik yapmak kolay değil. Yani önce o bütün o data science life cycle'ı takip etmem. Pre-processing, featuring vesaire, o model training, o da vakit alıyor. Dolayısıyla diyoruz ya, tamam digital twin real time, near real time diyor. İyi de I don't have always the time for that. O tarz şeyler. Diğeri mesela bu dediğim gibi, bu kavram var. Complex Adaptive Systems. Her şey böyle kolay değil. Mesela bazen ortam çok hızlı değişiyor veyahut çok fazla parametre var. Veyahut o parametre böyle causally connected değil ama feedback kontroller var. Bundan dolayı diyoruz ki, bu benim yorumum olarak, we need more than AI. Mesela o systems thinking. Mesela systems thinking'de var. Agent based models veyahut system causal loop diagrams. Biz o tarz araştırmaya bakıyoruz. Mesela farklı teknolojileri, teknolojiyi birleştirerek daha bir üst seviyeye ulaşmaya çalışıyoruz. Kendi içinde de mesela daha iteratif, repetitif yapabiliyor. İterasyon sağlıyorlar yavaş yavaş. Ama genelde biraz o konuda sorular olabiliyor.
Çok teşekkürler hocam.
Rica
Erkan,
ederim.
bir sorusu var. Sizin üniversitede yapılan çalışmayla ilgili. Hasat yapan robot ve sistemler üzerine çalışıyorlar. Bu sistemler yapay zekayı hayatımıza bu sistemler yapay zeka hayatımıza iyice girdikten sonra mı yaygınlaşır? Bu sistemlerin arazi şartlarını düşünce biraz zaman var gibi.
Yani bu var. Tabii o genel olarak bilimde deniliyor. State of the art, state of the practice diye bir var, kavram var. State of the art işte bilimde geliştirilen teknolojiler, teoriler. Genelde bu tarihe bakarsak 10-15 yıl alıyor deniliyordu. Şimdi biraz daha hızlandı, onu görüyoruz. Gerçek hayata geçmesi. Tabii burada da robotlar da aynı şekilde oluyor bence, her fikir olduğu gibi. Ee, araştırma yapılıyor, fakat bizdeki hep o yapılan araştırma odaklı zaten, pratiğe ulaştırılmaya odaklı. Ve ikinci soru tabii arazi şartları dediğiniz o bir başka şartlar olabilir. Mesela o teknoloji geliştirilir ama ortama pek her zaman uygun olabilir. O zaman knowledge transfer yapılıyor. Tabii o şartlardan arasında mesela maliyet de var. Mesela bizde birkaç projemiz var. Mesela Afrika ile yapıyoruz, Endonezya ile yapıyoruz. Ya farklı ortamlarda. Mesela oradaki o akıllı tarım kavramı farklı şekil alıyor. Önce farklı seviyede olduğunu fark ediyoruz. Mesela orada mesela bir bölgede örneğin e, henüz Endüstri 3'e 4'e geçilmediyse veyahut işte internet connection mesela çok kısacası çok iyi değilse orada zaten Internet of Things yapamıyorsunuz. Digital Twin yapamıyorsunuz. Dolayısıyla oradaki ortam biraz farklı oluyor. Yani burada bir taraftan teknoloji tabii robot diyoruz. Bu tamamen Industry 4 işte e,
Endüstrinin.
Independent Autonomous Systems ama o bir ortam için. Farklı bir ortamdaysanız o zaman stratejik olarak bakacaksınız. Ben şu an nerede duruyorum, nereye gitmek istiyorum. Ona göre işte farklı yol haritası çizmek lazım.
Hocam çok teşekkür ediyorum.
Rica ederim.
Değerli katılımcılar, sorunuz var mı? Zamanımızı da iyi kullandık. Sorunuz yoksa hocam çok teşekkürler.
Rica
Benim
ederim.
son Nano Open'da sizi ağırlamaktan memnun olduk.
Ben
Ee,
teşekkür ederim. Sağ olun.
Katılımcılarımıza da çok teşekkür ediyorum. Birkaç gün içinde webinarın videosunu, kaydını da YouTube kanalımıza koyacağız. Onu da buradan duyurmuş olalım. Güz döneminde görüşmek üzere. Herkese iyi günler diliyorum.
Çok teşekkürler. İyi bayramlar herkese.
İyi
Bedir
bayramlar.
Hocam, teşekkürler, iyi
İyi
bayramlar.
günler. Sağ olun. İyi günler. Görüşmek üzere.